Okay, so this section we really need for finding where series converge and diverge. This is a test that we will be using later. So here we go. These are all examples of improper integrals. And the first one is, this one's easy to see. We're going to infinity. So that makes this improper. This one is easy to see also because we can't have a zero in the denominator. So that's what makes that improper. This one is bad because there's a 3 that can't be in the denominator. And this one is bad because both negative pi over 2 and pi over 2 cannot be in the denominator. And this is how we handle these. We're going to identify the problem point, and then we're going to call that point B, and then we're going to rewrite. So in this problem, the problem point is B. So I'm going to write this as the limit as B approaches 0 from the right. So we're going from 0 to 1. Here's 0, here's 1. We're approaching 0 from this direction. So we need to have that little plus sign. And then just find the integral like you normally would. The integral of dx over x is just natural log of the absolute value of x. We are going to plug in both 1 and b. Natural log of 1 is 0. And so I have negative infinity. So that is going to give me infinity, which you know is not a limit. And because it's not a limit, we say that the integral diverges. If we get a number, we say that it converges. But when we don't get a number, we say that the integral diverges. So now this one, from 1 to infinity, the problem is infinity. So I'm going to take the limit from 1 to b. We can only get to infinity from one direction. I take the natural log of x from 1 to b. And I'm taking the limit as b goes to infinity. The natural log of 1 is 0. The natural log of infinity is infinity. This one also diverges. Let's do one that's a little more difficult. And we will have to use our L'Hopital's. So first thing is I need to rewrite it because of that infinity. I must show the limit as b is going to infinity. And then I can use tabular integration. I'm not going to show that, but I will show the integral after I use tabular integration. I need to plug in b and 1 and subtract. And I'm going to get rid of these negative exponents. I don't like that. So instead of writing it as e to the negative 2b, I'm going to write it as 1 over e to the 2b. So let's see. This one is going to 0. I'm going to use a different color. Let's go. Choose blue. So this one goes to 0. And these two are good. I don't know about this one. These two represent constants. So let's see. I'm going to use L'Hopital's on this. So I have the limit as b goes to infinity. And I'm not worried about the negative 1/2. I'll deal with that later. b over e to the 2b, which is infinity over infinity. So I can use L'Hopital's. This is a continuous function. So I get 1 over 2e to the 2b, and this goes to 0. So I have 0 minus 0 plus 1 over 2e squared plus 1 over 4e squared. And when I get a common denominator, I'm going to get 3 over 4e squared. Same with this one now. This one's a little bit different. We are going to get that this converges. You will eventually be able to look at them and tell that they converge. I have to take the limit as b goes to infinity. Oh, they used n this time, huh? And they should have put the n up here, but they didn't. I will. Okay, so the integral of 1 over x squared is negative 1 over x, going from 1 to n. I plug in my n, I plug in my 1. I take the limit as n goes to infinity. This goes to 0, that goes to 1. So my limit is 1. So that tells me that this integral converges even though it's improper. This is, the problem is infinity. And take note, they don't ask me to find this integral. They just ask me if it's convergent or divergent. Now I know the integral of 1 over x squared plus 1 is inverse tangent. So I could take the limit as b goes to infinity from 1 to b, 1 over x squared plus 1 dx. And that's going to be the limit as b goes to infinity, inverse tangent of x from 1 to b. That's the limit as b goes to infinity, inverse tangent of b, minus inverse tangent of 1. Now, I know inverse tangent of 1 is pi over 4, right? Now, inverse tangent of b, as b goes to infinity, this goes back to the graphs that I made everyone memorize back in chapters 3 and 4. Inverse tangent of b has a horizontal asymptote over an infinity at pi over 2. So pi over 2 minus pi over 4 is going to give me pi over 4. So this sequence converges. But that, integral converges. But that's not what they're asking. They're just asking if it converges or diverges. So I don't even have to find the integral for this. What I could have done was say, this integral is less than 1 to infinity of 1 over x squared, right? This integral, this fraction, is smaller than this fraction. So if this one converges, this one must also converge. And we already proved that 1 over x squared converged. So this one must also converge. And that's what you would say.